Hello, this is Connor Holman, and I want to talk to you for a few minutes about graphing piecewise functions. In this presentation, I have done the same problem two ways. When you see a piecewise function, I'd like you to go through and use this first strategy in your head so that you have an idea of what the graph looks like before you start implementing the details. Then when it comes time to implementing the details, the second strategy will be a more efficient way of doing it. So first of all, let's make sure that we know how to read this notation. I may read this as g of x equals 3x plus 7 for x values that are smaller than or equal to negative 2. G of x equals x plus 5 for x values that are between negative 2 and 3, not including the endpoints. And g of x equals negative 2x plus 4 for x values that are greater than or equal to 3. So let's start with the first line. We see that for x values that are less than or equal to negative 2, we are supposed to use the line y equals 3x plus 7. So we graph the line of y equals 3x plus 7. It has a y-intercept at 7 and a slope of positive 3. That means that to find more points on the line, I go up 3, right 1. I also graph the vertical line x equals negative 2, and then I shaded the part of the graph that had x values smaller than negative 2. So this is the graph of y equals 3x plus 7 for the x values that are smaller than negative 2. The second line tells us that for every x value that is both bigger than negative 2 and smaller than 3, we are going to use y equals x plus 5. I have drawn the line y equals x plus 5, the vertical line x equals negative 2, and the vertical line x equals 3. The green shaded part is the part of the graph that has x values between negative 2 and 3. Now we have g of x equals negative 2x plus 4 for all of the x values that are greater than or equal to 3. Now we have the graph of y equals negative 2x plus 4 and the graph of x equals 3. We've shaded the part where the x values are bigger than 3. So here's the part of the graph that we are keeping for that third part. And so here's what we get when we put it all together. So I would need to go through and add in the endpoints. So this is what's going on in my head while I'm doing the problem. Once I have an idea and understand how this is all working, then I can take some shortcuts. So I am showing you approach number 2 now, which is the way I might actually do it once I really have the handle on things. I know from my experience, when x is less than or equal to negative 2, that means I'm going to be drawing a ray. And so for each ray, I need an endpoint, and then I need to figure out how to get another point on the graph of the ray. This negative 2 right here tells me that my right endpoint is going to be at negative 2. The equal to sign tells me that it's going to be a close point. And so I take that negative 2 and I plug it into y equals 3x plus 7, which gives me a 1. And so that is the y value for that point. So I have a closed point that has x equals negative 2 and y equals 1. The slope of our line is positive 3, but I want to go to the left. So it's helpful for me to have a negative 1 on the bottom because that means left 1. And I then need a negative 3 on the top because 2 negatives divided gives me a positive. If I go down 3 and left 1, that gives me another point on the graph. You could also do this by just picking another x value. We knew that we were using x values smaller than negative 2, so you could take negative 3, you could plug it into the original equation. So if I plug negative 3 in here, I would have negative 9 plus 7 is negative 2. So that tells me that the point negative 3, negative 2 was a point on the graph. So that would be a different way to find a second point on your ray. So your ray would start at the point negative 2, 1, and then it would go through another point, for example, -3, -2. So that's the first piece of the graph. So now I have to worry about the second piece of the graph. So again, in my head, I know that this was a straight line. I see that I am keeping a piece of the line, so I'm going to end up with a line segment. And so that line segment is going to have two endpoints, and these are the x values for those endpoints. Because there's no equal to sign, they are both going to be open points. So if I plug -2 into x plus 5, I get 3. So I have a left endpoint at -2, 3. If I plug 3 into x plus 5, I get 8. So I have a right endpoint at 3, 8. Remember, those were both open. And so I get this. Since we knew it was a line segment, we can just connect those two endpoints. Okay, so for the third piece, again, straight line, and we're keeping the right-hand piece. We're keeping the x values that are bigger than 3. And so again, I know that I'm going to be creating a ray, so I need an endpoint and I need another point on that ray. The first endpoint is happening at x equals 3, so I plug 3 in for x. I get -2 for an answer, so I have the point 3, -2. So that's going to be my left endpoint. Because of the equal sign, it's going to be a close point. So the slope was -2, which is -2 over 1. So I can start at my endpoint, and I can go down 2 and write 1, and get another point on the graph. Or you could pick a next value that was bigger than 3. So for example, 4, and plug it in and find out what the point was, and you would get a second point on the graph. So put it all together, and that's the graph that you have. I hope that helps.